Hey guys, today we are going to look at complex fractions, and this is actually still 8.5. Um, it's the second half of 8.5, and just like to spend a separate day on it after doing some adding and subtracting, okay? But it's going to use a lot of the same skills that we've already learned in the past couple days with multiplying and dividing rational expressions and then adding and subtracting. So let's just go ahead and get started here. Do a couple examples and have you do a couple on your own. So what is a complex fraction? So it's a fraction in which the numerator and the denominator both contain fractions. Okay, and you can see some examples on the page here. To simplify means to rewrite as a single fraction. So rewrite as a single fraction with no fractions in the numerator and denominator. All right, and our goal is going to be the same as it was before to cancel out all common factors. All right, so here are the steps, and these are pretty condensed steps. First, create a single fraction in the numerator and denominator. Sometimes that's already done for you. Sometimes you need to do that by adding or subtracting. Okay, and that means that you might have to find an LCD. Okay, so I'm going to put a note here. Add slash subtract um, by finding LCD. So the first example we do, you won't have to worry about that, but all the other examples you will. Okay, step two, set up as a division problem that multiply by the reciprocal. This is really kind of the key. Okay, there's a couple of different ways to do complex fractions. The way I'm going to do it today, that I think is the most straightforward and easiest for you guys to understand, is to get the numerator to be a single fraction, get the denominator to be a single fraction, and then instead of actually dividing, multiply by the reciprocal. And we've done that before, right? When we did 8.4 multiplying and dividing, anytime we had division, all we did was flip the second term. So same concept here. Okay, and then third, simplify. Factor if possible. Um, cancel out common factors. All right, so let's go ahead and get started. This first one, okay? So it's a little hard to see in some of these, but right, this, let me use this line. This is an entire division line right there. Oh, that wasn't the best. Let me do that again. Right, this is like the big line. So you have a fraction in the top, fraction on the bottom. So our first step was create a single fraction. Well, we have a single fraction here, right? There's no two fractions to add in the numerator. So this one we can skip to step two, multiply by the reciprocal. So I'm simply going to rewrite this to be 7c plus 35 over c times c squared over c plus 5. Okay, so I multiply by the reciprocal. Now I need to simplify. So I need to factor where I can. So I'm going to take out a 7. It leaves me with c plus 5. Over here, there's nothing to factor. And now I'm going to simplify where I can. My c plus 5 cancels. I have a c squared and a c, so this just becomes c. And the c on the bottom goes away. And so I'm left with 7c. Okay, so that one's pretty nice, right? Now, that's not necessarily what we're going to focus on, but I want to make sure you understand that once you get it to a point where the numerator is a single fraction and the denominator is a single fraction, then you can just multiply by the reciprocal. Okay, so let's look at number 2 now. So here we need to do a little work. We have subtraction. So think of it as like the last unit, right? If I were to cover up the bottom, um, the denominator of the entire thing, then we would just be worrying about subtracting the top, right? So we need to find a common denominator for the top, right? So for this, the LCD is going to be 3x. And then we need to multiply each term by what's missing. So the first term is missing an x, so I'm going to multiply this by x over x. The second term is missing a 3, so I'm going to multiply this by 3 over 3. Okay, and there's nothing to do on the bottom because the bottom is already a single fraction. So when I do that, I'm going to get here, sorry, I'm skipping ahead, x squared over 3x minus 9 over 3x. And then the bottom stays the same, x minus 3 over x. Okay, now Now that I have the same denominator on the top, I can go ahead and subtract. So now I have x squared minus 9 over 3x, all divided by x minus 3 over x. Okay, now I have a single fraction. Single fraction in the numerator, single fraction in the denominator. I'm going to turn it into multiplication. So x squared minus 9 over 3x times, now flip, right? When you divide, you multiply by the reciprocal. So times x over x minus 3. Okay, and now you may have seen it already, but we need a factor. We can factor this guy right here. So let's do that. We have x plus 3, x minus 3, I'm running out of room, divided by 3x times x over x minus 3. Let's cancel out common factors. X minus 3 cancels out, x minus 3 cancels out. We have 1x on top, which cancels out with the 1x on bottom. And we're left with x plus 3 over 3. Okay, so again, you have to get a single fraction in the numerator, get a single fraction in the denominator, and you do that by using the tools we learned the past 2 days and adding and subtracting. Okay, once you have a single fraction in each of the numerator and denominator, then you can just multiply by the reciprocal. Okay, so flip the second term and then multiply like we did in 8.4. All right, try the next problem on your own and I'll go over it. Okay, so here we go. The top does not have a single fraction as of yet. Okay, so this needs to be added. So our LCD is going to be 3p. So what's missing from the first term is a 3, so multiply by 3 over 3. What's missing from the second term is a p, so multiply by p over p. Okay, the denominator we don't need to worry about because it already is a single fraction. All right, so let's multiply out. We're going to get 3 over 3p plus 2p over 3p all over 1 over p. Now that we have the same denominator, we can add the fractions in the numerator. So we're going to get 3 plus 2p over 3p all divided by 1 over p. All right, now we have single fractions. So we can now multiply, change this to multiplication. So 3 plus 2p over 3p times reciprocal of 1 over p, which is p over 1. All right, cancel out common factors. All we can cancel out is a p and a p. What does that leave us with? On top, we have a 3 plus 2p. On bottom, we have a 3. And that's your final answer. So hopefully you were able to work through that one. Okay, let's move on. Slightly harder problem, but same steps and same concept. So again, we need a single fraction in the numerator and we need a single fraction in the denominator. We do not have that. Okay, so we need to almost approach it individually. So we need to add the two fractions in the numerator, and then separately we need to add the two fractions in the denominator. So as always, first thing is our LCD. Okay, well, we know that this is going to factor the 5 times a plus 3. So this ends up being our LCD. So what is missing from the first term is a 5. So we multiply this by 5 over 5. What's missing in the second term? Nothing, right? The denominator already has the LCD. Okay, let's look at the bottom. Our LCD over here is also going to be 5 times a plus 3. So again, what's missing from the left term is 5, so we multiply 5 over 5. What's missing from the right term? This time it's a plus 3, so we multiply by a times a plus 3. Now, I just want to point out real quick, guys, this is just, happenstance, a coincidence that the fractions in the numerator and the fractions in the denominator have the same LCD. That is not always going to happen. All right, so let's see what we get here. All right, let's multiply out. We're going to get 5a squared. Let me rewrite that so it's not so messy. 5a squared over 5 times a plus 3 plus a squared over 5 times a plus 3. All divided by 5a over 5 plus a plus 3 plus a plus 3 over 5 times a plus 3. All right, we have the same, we have common denominators in the top, so let's add them. So we combine like terms. 5a squared plus a squared, it's going to get us 6a squared over 5 times a plus 3. Denominator, we're going to get 6a plus 3 over 5 times a plus 3. All right, now we have single fractions, one single fraction in the numerator, one single fraction in the denominator. Now we can flip it. Okay, so top stays the same. Now flip the second one, so multiply by the reciprocal. So now it becomes 5 times a plus 3 over 6a plus 3. All right, cancel out common factors. What can we do here? A plus 3 can cancel out. 5 can cancel out. Let's leave it like that for right this second. And we're left with 6a squared over 6a plus 3. I think I'm missing something here. Okay, and then let's factor out on the bottom. So the top is 6a squared. The 2's are messy today. Let's factor out a 3. That leaves us with 2a plus 1. Okay, and now we can do some canceling. 6 divided by 3, that just equals 2. So 2a squared on top divided by 2a plus 1. That one looked a little funny, but that's our correct answer there. Okay, so try the next problem using the same tools. Get a single fraction in the numerator, get a single fraction in the denominator, add or subtract to get there, and then multiply by the reciprocal of the denominator. Go for it. Okay, so here we go. LCD of this would be just 2. So first term already has 2 in the denominator, so the second term needs 2. So we're going to go 2 over 2. LCD of the bottom is 16. So the first term already has 8, so it needs to get to 16, so it needs to multiply by 2. Okay, so what do we have here? So first term stays the same, k squared minus 9k over 2. Second term, multiply top and bottom by 2. That gives us 20 over 2. Okay, denominator, we're going to have 2k over 16 minus k plus 5 over 16. Okay, let's just keep going this way. Now we have the same denominator on top, so let's combine. So we're going to have k squared minus 9k plus 20 all over 2. Denominator is going to be 2k minus k. So first off, recognize that this whole thing is being subtracted, which means this negative gets distributed to each. So it's going to be k minus 5 over 16. Okay, we now have a single fraction in the numerator and a single fraction in the denominator. So let's change it into multiplication. So k squared minus 9k plus 20 divided by 2. Now multiply by the reciprocal, 16 over k minus 5. All right, now factor. The left term is going to factor to k minus 5 times k minus 4 all over 2. And the right term is already factored. Cancel out common factors, k minus 5. 16 over 2 is going to simplify to just 8. So that leaves us with 8 times k minus 4. And that's all we need to do. And that is our final answer. So hopefully you were able to work through that one. And if not, hopefully it helped by me walking through this. All right, guys, that's it for today. Homework is 4 short problems. Want you to focus on the steps of it rather than just drilling too many of these problems. All right, thanks, guys.